So from the previous video when we looked at algebraic division, we worked out that if we could divide the polynomial with a certain term and we got a remainder of 0, then that term we can conclude was a factor or a linear factor of the original polynomial. However, in some questions they might not give you this original linear factor, in which case we have to actually find it ourselves. Now performing algebraic division is not too difficult, but the problem is it's quite long, and so we don't want to be doing that or repeating that every single time. And instead what we can do is to find the linear factor is use something called a factor theorem. Now the factor theorem states that if f of p is equal to 0, then x minus p is a linear factor of the polynomial, and vice versa. So if x minus p is a linear factor, then f of p is equal to 0. That's the definition of the factor theorem, but let's just use it and you can see in more clear detail how it works. So let's say we have this equation here, y is 3x cubed plus 8x squared plus 3x minus 2. And we want to find a factors or the d factors of this original polynomial. Now what we want to do is actually plug in some values into the function. So if I call that initial cubic equation f of x, it's basically trial and error. So what you want to be doing is plugging in values of x into that original function, and ideally we want to find the value of x which will give us a result of 0. So let's try plugging in f of 1. If I do that, I get 3 plus 8 plus 3 minus 2, 12. We know that 1 is not going to be a factor. Let's plug in f of 2. Same thing, I get 24 plus 32 plus 6 minus 2 is 60, once again not a factor. Let's now go for f of minus 1. So that will result in minus 3 plus 8 minus 3 minus 2, and actually comes out to 0. What does that mean? Well, it means that our p is minus 1, and therefore if you go to the original definition, x plus 1 is going to be a factor of this original cubic function. We found one of the linear factors. And with this, what we can do now is we can perform algebraic division. And if I do that, I'll get x plus 1, and I'll get as a quotient 3x squared plus 5x minus 2, which we can factorize further to get our final, the three linear factors as x plus 1, 3x minus 1, and x plus 2. So you can see, rather than having to perform algebraic division many times, just plugging in these random values into the original function and trying to find the value which gives us 0 allows us to find these linear factors much more quickly. Now I'd hint here, so when you're actually plugging in these values of x, ideally what you want to start off with is always try plugging in 1 and minus 1, and you want to go away from that. So maybe try 2, 3, or minus 1, minus 2, minus 3, and one of those values will give you a value of 0. In most cases, there is going to be either someone within that range, but sometimes they might ask, well, you might have to put in like a half or like minus a half, but those are the rare occasions. Right, so using this definition, we can also solve other questions such as this one here. So in this case, we're told that x plus 1 and x minus 2 are factors of this polynomial, and they want us to find the c and d values. We can use the definitions. So if we know that x plus 1 is a factor, we know that x minus 1, if we plug it into the function, should give us a value of 0. And same thing for if I plug in f of 2. So let's go ahead and plug each of them in. So if I plug f of minus 1 in, I'll get minus c plus d plus 9 minus 10 is 0. Rearranging, I'll get minus c plus d is 1. Same thing for f of 2, I'll get 8c plus 4d minus 18 minus 10 is 0. Let's rearrange to get 4c plus 2d is 14. What you notice is we get two simultaneous equations, which we can solve because we've learned it before. And if you do, you should get values of c is 2 and d is 3. So these are just some like different types of questions, but they're all using the definition of a factor theorem. Go ahead and practice some of these questions. Once again, as I said, it is trial and error in most cases, but they will be within the range of -3 to 3.